It's our last one! Woohoo! And what's beautiful about this one is you might have a problem or two in your homework about it, but even and odd, what we're moving into, you don't have to know it. You don't. You are allowed to do extra work. This even and odd game, this is only so there's shortcuts through the problem. But if you don't want shortcuts, ignore this section. You can go the long way and still get answers. That's not a problem. So you can go ahead and do that. But if you want shortcuts through problems, we'll need to know our even and odd. Now, even and odd will come back later in the class and it'll need to be known. But for right now, again, you don't have to know these. You can go the long way. It's fine. While I do a problem in 2 steps, you can do it in 12. It's fine. You don't have to do this. Do you kind of get what I'm doing there? Do you get what I'm doing there? Do you get what I'm doing there? Because I know students don't want to do more work. Even and odd, and you look at this and you're like, what the frick does this mean? Well, you remember from algebra, even and odd, don't you? Why don't we just stick with numbers, even and odd? You know, 1's odd, 2's even, 3's odd, 4's even. No, even and odd. Okay. So odd functions, and this is just the game. We show that sine, cosecant, tangent, and cotangent, they're odd. Which means if you have a negative angle, you can pop it out to the front. And then we get negative sine of a positive angle. You're like, that still makes no sense. Okay, that's fine. Don't worry. I got to give you some examples. Just writing this stuff down doesn't help. And then we find out that cosine and secant are the only 2 even ones, which means if you have a negative angle, you can just ignore the negative and just do it at the positive angle. Again, what the frick does that mean? Here we go. Here we go. Well, let me explain it with algebra just in case. Let me give you an example of an odd function. Y equals x cubed. If you graph it, it goes like this. Whee! Okay, cool. But they share points. 1 comma negative 1. Oh, I have to not write that as y. I have to be fancy. I have to call it f of x. Oops. I write negative 1. So this point right here is 1 comma 1. So if I look at f of negative 1, if I want to have that answer, since it's odd, I know I get the same answer as f of 1. I just have to change the sign. So it's just negative 1. I don't know if that makes any sense, but much easier to find an odd and an even when dealing with algebra. Let me draw an example of even in algebra. Y equals x squared. Y equals x to the 20th. Y equals x to the 40th. Even numbers. It's a parabola facing up, saying it doesn't matter whether you plug in negative 1 or positive 1, you're still going to get 1. That's what this is saying. It doesn't matter what the negative or positive angle, you're still going to get the same answer. So let us do a couple practice ones. So if I give you this, and this is the reason why. Sine of negative pi over 3. That is not between 0 and 2 pi. It's not. It's not. It's not. So we could do this. You could add 2 pi to it. So this is showing like, oh, we could say that this is the same thing. We could just add 2 pi to our answer. Or the angle, not the answer, the angle. And I'm going to skip the steps, and this turns out to be 5 pi over 3. And then we can solve like I did for that worksheet thing. That's no problem. You can do more work. You are allowed to do more work. I don't mind. But we could just use this. See the negative? Just pull it out to the outside and say this is the same thing as negative sine of positive pi over 3. Now we just go check our table. You know the little table? Sines, the angle, and we find out pi over 3 goes with root 3 over 2, so we just put it inside there and go, oh, the answer is negative root 3 over 2. Maybe you don't like that. What if we had cosine of negative pi over 3? Oh, that's an even function. All it's saying, ignore that. It's the same exact thing as cosine of positive pi over 3, and we could write down our answer as a half. Instead of having to do cosine of 5 pi over 3, figure out what quadrant it's in. Figure out what the reference angle is. We can just look at it and go, oh, cosine, it doesn't matter. It doesn't matter. Now, I don't want you to think that just even functions only pop out at positive answers. They don't. They don't. I'm going to give you an example. Let's go through. Cosine of negative 2 pi over 3. It's an even function, so we can ignore that negative. We can go, oh no, this is the same exact thing as cosine of 2 pi over 3. Positive. We just ignored the negative. That's nice. If nothing, if I was a student thinking this is too much, I'd be like, well, wait. Cosine's even? You mean those negative angles? I can just ignore them and just erase the negative and I'm going to get the same answer? Yes! And you'll see it when we start graphing. So to do this, we'd have to go through. There's still more work to do. I mean, there's no matter what, there's work. But as I'm messing with this thing, I'm like, okay, well, the reference angle is pi over 3. That's in quadrant 2, or in quad 2. So this is going to be equal to negative cosine of the reference angle. Okay? Quadrant 2, cosine's negative. So we get negative 1/2. Or you can add 2 pi to this and find out that you're down in the third quadrant with 4 pi over 3. But cosine's negative there as well. You'd still get the same answer. It's just a quicker way of getting through the problem. So again, you have every right to do more work. And again, you don't have to know these yet. You can solve everything except for maybe a homework problem or two, but I think all those homework problems are multiple choice. And I know most of us just click the button to get through so you can get your homework done for that 10% of your grade so you can fail the 80%, but that's up to you. I can't force you to do anything. I can't care about your grade more than you do. You want to just go through and do it, you do you. But again, to recap, you don't have to know these except for a couple of homework problems. You can solve everything without it. So possibly you might want to wait. No more sarcasm in my voice. Possibly you might just want to wait to learn it later. Or you might want to know it now, get it handled so you can do less work. Make that decision. Either way, you're good. All right. We finally made it into this freaking session. Let's go.